Hello and thanks for joining me today. This is Danny and welcome back to my Unstable 1.8 series, episode number 16. Today is going to be all about Psi. I've been listening to you guys in the comments, and it seems some people are asking for Psi, a few people asked for some more Thaumcraft, and a couple people asked for me to play Blood Magic, which I've actually never played before. Well, I decided on Psi for this episode, and I'm actually going to be starting a separate Thaumcraft 5 complete playthrough series, so that we can focus in this series on brand new mods that we haven't played with yet, like Psi. So Psi is all about kind of programming your own spells. It's kind of an interpreter of sorts that allows you to put different programming pieces together to do some really cool OP stuff. And it's the possibilities are ridiculously just making my head spin. So I'm really excited to get into this mod with you guys. Get started with Psi. All you really have to do is one thing. Press the letter C. And you get this little thing that tells you how to get started with the mod. And then as we go on with the mod, we'll be pressing letter C to get all of our other information too. So I'm not going to read all this stuff to you, but if you want to pause and read that, you most certainly can. But I am going to make ourselves a CAD assembler, because that's basically what that screen just told us to do, to create a CAD assembler and an iron CAD assembly. I'm having some weird issues with JEI and easy storage for whatever reason. I guess we'll just put it over here. I'll put it over in this area actually, because we're going to be playing outside a lot with this. So we put that in there. Oh, that's right. So we have to make our casting assistance device. Ooh, check out the sound effects. Nice. Okay. So then we can go. We should be able to shoot this. Hooray! We just leveled up. We got 1 level point. Unequip your CAD and press C to use it. Okay, so we just made ourselves some Psi dust, which is an ingredient we're going to be using a lot of. And now that we've done that, we have this little tutorial. Every time we level up, we get a bunch of information about the mod and what we can do next. And then we also open up a couple of spell pieces. So for our first level, we've opened up the trick debug piece and the selector caster piece. And we'll see how those work in a second. And this first one is the longest. So not all of them are going to be really all this long. But you'll probably want to read all that. I'm not going to read it to you. You can do that on your own. But I'm going to show you basically what it says. So first off, it's telling us we need to make a spell programmer. That's this guy. So we're going to use our little piece of Psi dust that we just crafted. And it's also telling us that for our CAD assistance device, we're also going to want a core. And we're probably going to have to go with the basic core, because this one requires Psi metal, which we can't make yet. Or all the rest of them require Psi metal, and the higher ones require the Psi gem, which we also can't make yet. So actually we are going to need some more Psi dust. So I don't know, can we do a bunch of these at once? Let's see. We can. Nice. Okay, we're going to need that. We're going to need a socket. And again, we have different levels, and we're probably going to have to go with the basic. And we're also going to need a battery. And that's really all that we're going to need. Whoops. Battery. Again, we'll go with the basic. And then we can also do a colorizer. Which is not something we need. It's just something that allows us to make our little gun different colors. So it's definitely not something we need. And actually, I'm not going to make it right now. And then we can go. Actually, wait. First, we can change this back to our iron CAD assembly, so that we can then stick it in here with our little components. And now we will have a casting device. As you can see, as I added these things, it changed these numbers over here. We'll talk more about what all these different numbers mean as we get into making spells, and also as we start updating the different components, we'll look at what the different components give us. And then we have our spell programmer. So now the other thing that we're going to need is bullets. May as well make a couple of them right away. Again, of course, we have all the different levels. We have projectile, we have loop cast. We're just going to make the regular old spell bullets. Let's just make... These don't stack, do they? Nope. We'll just make a couple of them. And now we can go in here and click, and we can see the two pieces that we have available to us. So we have a selector, and then we have the trick debug. The trick is the thing that actually does something. So we set the trick here, and then the trick requires, or the trick takes two parameters. So if you're a programmer, you might understand the idea of parameters. Basically, a parameter is something that you send into it. It's some kind of piece of information that it takes, and then our caster actually returns something. So if we shift click over this, we can see that left arrow means that this piece provides a piece of information. This one, the left arrow says none. It doesn't return a piece of information, but it accepts two pieces of information, a target and a number. And the parenthesis around the arrow over number means that that's optional, which is good because we don't have any means to give it a number right now. So our trick debug requires a target, but we can tell it that the target is on the left side. So the caster, which is us, whoops, I did it wrong. The caster, which is us. And now you can see, wait, let's do it wrong once. You can see that little red there is showing us that it doesn't have all the information that it needs. So we have to tell it that the target is on the left side of it. So all this thing is going to do is it's going to take a target, and it's going to take a number optionally, and it's going to print that information out in our chat. And then we have to give it a name. We'll just call it debug. Whoops. So this isn't a very interesting or exciting spell, but this is the debug. It's basically a kind of doing two things for us. One, it's kind of a way for us to practice using the programmer, and it's also giving us a programming piece that we can use in the future to debug our spells, to figure out exactly what they're doing. So we right click on it with a bullet, and now this bullet has that spell that we just created. So now we can go over here, stick our little CAD, our casting assistance device, in here, and put a bullet in the device. And we now have a spell in our caster. Hooray! And if we run the spell, we leveled up. Hey, how come it didn't have a big noise? Oh well. And you can see in our chat, it's showing us the caster, entity player, Danny DJ DK, and it's saying what our location is, and so on and so forth. So that's because this target is us, selector caster. That's me, because I'm casting the spell. The C key is the only key that you use in this mod. When you're holding your caster or your CAD, if you hit the C key, you're going to get the option of the different spells. And this particular CAD can hold 4 spells because of the properties of it based on the parts that we gave it. But if you're not selecting it and you press C, then you get your tutorial menu. So what happened is that, see this little red thing here is telling us that this is the required piece that we have to use in order to move to the next tutorial, to the next level. So we use the trick debug. So now we are able to move on to tutorial number 2. In level 2, we're given two more pieces, a number piece, constant number, and a connector piece. And we have to use the constant, because it's red, number, in order to move on to the next level. So, and remember, this guy takes a target and a number, so we can just add number. Oh, and we also have the connectors. And actually, let's just play with the connectors, even though we really don't need one, but just so we can see how they work. Let's say we decided to put our number up here. Okay, then we can add a connector, like so. Oh, wait. There we go. And then we can tell this guy that our number is on top. So it's basically pulling this number down here. So let's say we can just type whatever. Can we 223, whatever. Or we could type 4, whatever. It doesn't matter. So now we have a new spell. Why don't we steal our bullet out of here? Our same debug bullet. And now when we cast this spell, we see the number 4 and the entity, blah, blah, blah. So level 3, we get 2 more pieces. We get the add motion, which will add motion to an entity. And you can see that it takes an entity. It also takes a direction and a speed. Now the direction is a vector, which we have another entity, or we have another piece which returns a vector, and that is the vector representing the direction that the entity is looking, or that an entity is looking. Add motion. And this requires 3 things, as we saw before: the target, direction, and speed. The target would be an entity, and I'm actually going to put that up here. Of course, the only entity we have is ourself, so that would be the caster. And then it also requires a direction, which is a vector. Now we're actually going to use, well, we only have one way to produce a vector, and that is a look vector, the one that we just got. Where is it? There it is. Which requires a target. So again, the target would be the caster. And then we also need a speed. So that would just be a constant. I'll just throw that down here for simplicity. We'll set that to 3. And then we're also going to be putting a connector here. A connector here. And then we have to tell it that our speed number is coming from down here. Oops, no it's not. Down here. So now that everything is valid, we have all this information to the right. We can see the complexity. This is basically the number of actions. And this does not include debug. We can see the potency. That's the power of the spell, which is limited by our CAD device. That's redundant. Our casting assistance device. And then the amount of energy it's going to take. And this is going to take, normally it would take 270. However, in our case, it's going to take 385 because our CAD is so inefficient. The amount of tricks. So we only have one trick. We're just doing the motion trick. And then the bandwidth. So that would be basically the greater of width or height. So if we were to set this to 4, or 34, whatever, you can see that it requires 4,046 potency, which is way more than our CAD can handle. And the Psi cost for us with our CAD is going to be 49,542. Obviously, that would kill us because if we run out of Psi energy, it actually starts taking health points. So we don't want to do that. Actually, we could do. Oh no, we can't even do 4. Even if we do 4, we're going to be using too much Psi energy. We could do it, and it might not kill us actually. But let's just stick with 3, not 43. 3. And this one we're going to call. Whoops. Okay, I guess you have to click out of whatever you were clicking at or whatever you were in, otherwise it won't let you type. So we'll call this move. And then we're going to take, actually let's just take our other bullet this time. And click, we get our doo-doot, and then we stick this guy in here and that guy there. And now our CAD assembly has, our CAD has 2 spells. So we can choose between move and debug. We're now moving. Let's go outside for this. And we go, boom. Hooray! We moved. Now we have another level. We're now at level 4. We click to learn. We get more information. And we have 4 more tricks. Or 4 more pieces, rather. So here's where things start to get fun, because now we can blow stuff up. We have the explode trick, which requires a position and a power. We also have entity position and a vector raycast, which follows a vector until it reaches a block. And then we have the error suppressor. So ultimately, we want to explode stuff, right? Which requires a position and a power. The position is a vector. For position, we're going to use the vector raycast, which we can see returns a vector, but it requires a vector and a ray and a number. So the first vector is position, is basically the starting position of the vector that it's going to return. So that would be our position. So we're going to, entity position of the caster. So our ray cast, the ray, basically, the arrow, starts at the position of the caster. And then we also need a ray, and that is something we can get, from entity look. So entity look is basically the direction that we're looking in. And this, of course, needs a target, and the target is us, the caster. So we're going to have to put some connectors here. Okay. And then we also need a max, which is actually optional. The max is 32. 32 blocks. We can cast this spell 32 blocks in any direction. If we want the max to be less than that, then we would specify a number, but it's optional. That's what that little purple thing is telling us. So trick explode. So this vector raycast will then give us the point of the block that we're looking at. So there's our position, and then the power is a number. So we'll just throw a number up here. I don't know how big we can do this. Let's see. 3, that's too much. 2, that's too much. 1 is good. Okay. So we could only do an explosion of power 1. Up to 32 blocks away we can be, and we can just point it at the block, and it blows up the block we're looking at. So there's no arc like there would be with a bow or anything like that. It's just directly right at the block we're looking at. That's pretty cool. We now can do any one of the level 5 tutorials, entities, numbers, and vectors. And by the way, when you have your book open, the game is paused if you're in single player mode. So in Entities 101, we now get lots of pieces that allow us to select other entities other than ourselves. Items and nearby living things, so that's everything living, nearby enemies, nearby animals, projectiles. Oh, that's cool. Like arrows and such. And we can also get the motion of any entity, including ourselves or any of the other entities. We can get a random entity out of a list. These all give us lists of entities, which we can then grab an entity from. Remember before we were out there shooting our little, making our little explosions, but our explosion spell, would be cast at the block that we're looking at. So if there was an entity standing in front of the block, it would just pass right through the entity, and it would go to the next block in the direction that we're facing, whether an entity is in the way or not. What I would like to do is to find the nearest entity to the block that I'm looking at and set off an explosion there. Let's see how that works for us. There we go. There we go. Nice. Oh, that's awesome. Oh, I love that. Oh, that's great. Oh my god. I love this spell. I can hit from 32 blocks away and it basically sets off an explosion at the position of the nearest mob that I'm looking at, of the nearest mob to the block that I'm looking at. Look at that. Oh, is that... It just launches them in the air. Nice. And I've got it set to within 6 blocks, so I can look within 6 blocks. Like even if I'm not looking right at them. Oh, I love that. Oh my gosh, I think I just found my new favorite weapon. I knew I was gonna love playing with this mod. So here it is. Trick Explode. So it requires a position and a power. The position that I'm giving it is an entity position. So unlike the other one that was doing a block position, this one is actually giving us an entity position. The position it's the position of an entity in the list of nearby enemies closest to the vector ray cast that I am looking. So the selector caster, entity look, entity position. The ray cast, the position is my position. The ray is my look direction. And then I've got this point that I'm looking at, this ray cast, is going both into the enemy selector. So this is the selector of nearby enemies. It gives us a list of nearby enemies that are close to the point that I'm looking at. The position, of course, is this vector ray cast. The radius is 6. So it's just looking within 6 blocks of the block that I'm looking at. And then it's grabbing out of that list of entities in that 6-block radius. It's grabbing the one that's closest to the point that I'm looking. So there's no way to just say, hey, give me the mob that I'm looking at. You have to get a list of mobs that are near a point, in this case the point I'm looking at, and then select from there the one that's closest to the point I'm looking at. So it's kind of a roundabout thing, but hey, it works. So that entity position is the position of the explosion, and the power is 1 because that's all we can do so far. The bandwidth tells you the longest height or width of the spell. When I first did this, I had the constant 1 down here, and it wouldn't let me do it because I can only have a height and width maximum of 5. So I ended up moving the constant up here, and then it worked. So it's the same spell, but you do have to think about how compactly you position these things. So we're definitely ready for the next level because we did do the closest to point, and we had a lot of fun with it. So we can actually move on to level 6 now, or we can do more with in level 5. We also have numbers and vectors in level 5. Actually, before I move on to level 6, just a quick note on numbers and vectors. Numbers basically obviously give you some math functions, just some basic arithmetic functions. Just one thing to note is that some functions or some pieces require numbers, and some pieces require number constants. Like all the selectors require number constants. The Trick Explode requires a number constant for the power. These are number constants. They're just numbers. The arithmetic functions all return numbers, which are not number constants. So for instance, you can't do a Trick Explode. You can't say you can't have some arithmetic expression that determines the power of the explode. I'm guessing probably because then you wouldn't really be able to determine the potency and the cost of the spell. So you have to use number constants where number constants are required. Where numbers are required, like just regular old numbers, like for the trick debug, you can use constants or numbers. Now, since Psi came out, there's been a lot of discussion about vectors in the community. And some of it's been helpful and some of it's been not quite so helpful. And I'm going to try to add to the discussion a little bit here. And explain vectors in a way that hopefully doesn't add to the confusion. To put it simply, the definition of a vector is an ordered list of numbers. That's it. The end. Have a nice day. That's the end. That's it. That's what a vector is. It's an ordered list of numbers. Now, of course, we need to know a little bit more about how vectors work than that, and the kind of vectors that we're going to be working with. So for the most part, well, no, not for the most part, 100% of the vectors that we're going to be working with are going to be 3D vectors. And a 3D vector is an ordered list of 3 numbers. That's it. It's an ordered list of 3 numbers, one number representing each of the dimensions, which in the Minecraft world are on the X, Y, and Z axes. So the order of the list is X, Y, and Z. In Psi, we're basically going to be doing 4 different things with vectors. We're going to be kind of looking at 4 different categories or types of vectors. The first type of vector that we're going to be working with is position vectors. Now, if you've been playing Minecraft for a little while, you've already been playing with position vectors. So there's no mystery here. A position vector is an ordered list of numbers representing your position in the world. That would be your X, Y, and Z axis. That's what you see when you look under F3, where it says X, Y, Z. That's what we can see on my map in the upper right-hand corner, except that the order is different, and the order, of course, is very important. So my X, Y, Z position vector would be minus 185, 66, 325. That's my position vector. Of course, everything in the Minecraft world has a position vector. These blocks all have a position in the coordinate system, and it's as simple as that. That's a position vector. The second type of vector we can call a direction vector, and that is a set of 3 numbers representing a direction. So like the direction that we're looking. So far we've played a lot with the look vector. That is a vector that describes the direction that we're looking in the XYZ, in relation to the XYZ axis. So for instance, to give you a very simple example, if I look straight down, I'm not looking in the X direction or the Y direction, I'm looking exactly straight down. My look vector right now is going to be 0, minus 1, 0. Because X and Z are both 0, because I'm not looking at all in the X and Z directions. Y is minus 1 because I'm looking down. If I look straight up, then it's going to be 0, 1, 0. Although technically I'm not looking straight up. It's impossible to look straight up in Minecraft. You're always looking slightly in one direction. But now if I'm looking down and I gradually look up toward the south direction. Now south in Minecraft happens to be the Z axis, the positive Z direction. So as I look up, my Y axis, I'm sorry, yeah, that's right. My Y number is going to approach 0, and my Z number is going to approach 1 because I'm looking toward the positive 1 direction. If I look down at a 45-degree angle, my look vector is going to be 0, minus 0.5, 0.5, because I'm looking halfway in the minus Y direction and halfway in the Z direction. Most of our look vectors are going to have more complicated numbers than that, but they're always going to add up to 1. The absolute value of the 3 numbers is always going to add up to 1, which basically means that the magnitude of the look vector is always going to be 1. We don't really need to understand what that means, but just know that those 3 numbers will add up to 1, and they will represent the direction we're looking in. So if we're looking straight north, we're looking in the minus Z direction, so our look vector is going to be 0, 0, minus 1. It's almost impossible to look directly south, or directly in any direction, really, except down. That's really the only direction that you can look directly in. But that is the directional vector. The third type of vector is what we call an axial vector. It's also a direction vector. When we're looking at a block, each face of the block is going to be facing a pure direction, one of the 6 directions, and it can be represented with an axial vector. So, for instance, if we're looking at the north face of a block, we're looking at the north, again, is minus z. So we're looking at the 0, 0, minus 1 face of the block. If we're looking at the top of the block, we're looking at 0, 1, 0, because that's the positive y direction, and so on. And the fourth type of vector, and perhaps one of the more complicated vectors, is a Euclidean vector. Now, you don't really have to remember that name, but basically a Euclidean vector is a vector that represents a direction and a magnitude, or a length. So technically, the direction vector that we talked about earlier is a Euclidean vector with a magnitude of 1. Again, you don't really need to know that per se, but that's just to give you an example of a Euclidean vector. Euclidean vectors are, in Minecraft, they're generally used, well, in Psi, they're generally used to determine the direction and the distance. So if we're looking at a block, like that block right there, there could be a vector that represents the distance of that block from us and the direction of that block. You could almost think about it as a position vector, but the origin is our face. So our face is 0.000, and that block would be in the XYZ value relative to 000 at our face. And that's really all we need to know. I mean, Psi uses all these different types of vectors to perform math functions to determine the things like where we're looking, like the vector raycast can determine what block we're looking at. You know, I mean, the beauty of it is that Psi does it for us. We don't have to do any complicated vector math. We just basically need to understand what the different types of vectors are and how to use them in Psi. And we just need to make sure, just so that we can give them the right vectors, give Psi the right vectors that it's looking for. If we understand the difference between a vector representing a position, one representing a direction, and one representing a direction and distance, it's enough for pretty much anything cool that you want to do with this mod. And unfortunately, that's all we have time for today. I was actually hoping to get through all the tutorials. Looks like we're going to have to continue in the next episode. Just to tell you a little secret, I've already recorded the next episode, and we did get through all the tutorials in the next episode, and we actually got to do some really cool spells. My favorite one was one that works like the Tinker's Construct hammer, which breaks a 3x3 area of blocks on the plane of that you're looking at. So, you know, I've seen a lot of spells out there that dig kind of tunnels in the XY or ZY axes, or planes. This one actually will do just like the hammer. It's going to do whatever your plane you're looking at, which is actually adds quite a bit of complexity, believe it or not, to the spell. But it's better than the hammer because it's instantaneous. So it's so cool. But we're going to look at that, and we're going to kind of talk through how the vectors, how we use the vectors and the things that we just learned about vectors today in order to make that happen. And then in the following episode, I'm actually interested in hearing what you guys would like me to do. So please feel free in the comments to let me know if you have any ideas of different spells that I can make. And of course, I can show you the spells in the video, and I can also share them with you in text that you can actually copy and paste them and use them in your own world. So that is really cool. That is a really nice feature of this mod. So if you did enjoy this, please don't forget to click the like button, and I hope you join me next time. Thanks for watching.